All right, today we're going to be adding and subtracting radicals. So for a second, pause this, or I'll pause it, and take a second to see if you can add or subtract these. All right, so when you combine these two, since the x's are the same, 2x and 3x is 5x, right? You're just adding the 2 and the 3 together, saying how many x's you have. Same here, I have 5y's and I take away 2y's. So that leaves me with 3y's. Now, what's 4x minus 4x? It's 0. It's not 0x, it's not x, it's just 0. It's gone, right? And then 8y minus 2x. Well, if you look at these two, there's nothing you can do there. You can't actually get 8y minus 2x or change it or simplify it in any way. All right, so adding and subtracting radicals. So the procedure is you reduce the radicals. Okay, I'm writing with my finger right now, so I'm sorry. So that's what we did yesterday. So by completely, I mean you have to make sure you picked the largest perfect square. So this is what we did yesterday, or the last lesson. Okay, and then add or subtract, same as we did with the x's and the y's, we're going to add or subtract like radicals. So a like radical is a radical that has the same number underneath it. Okay, so radical 2 plus 3 radical 2, these are like radicals. They are the same. The number under the radical is the same, or the radicand is the same. If we add these two together, 3, remember, 3 plus 1 is 4. And that's it. That's how we add. Done? Can I just stop now? No, I'm kidding. All right. So these are already reduced. Awesome. There's no perfect square that's less than radical 2. So then 2. So there's no perfect square that I can divide into that. So I am going to, that would be significant. So all I do is I add the outsides. What's inside the radical stays the same. It's just like x's. I have 5 radical 2's on a sheet of paper and 7 radical 2's on the sheet of paper. So if I put them together, I have 12 radical 2's. The thing under the radical stays the same. All right, so here, I can't reduce radical 3. There's no perfect square underneath it. Here, I can't reduce radical 2. They are not like, so this is just like 2x minus 3y. I can't do anything with it. That's it. It's done. Trying to trick me, Miss Barris? What the heck? Okay, this one. So now I want to reduce these. Now, 4 is in our list. So the perfect squares, remember, are 4, 9, 3 times 4 times 4, 5 times 5, 6 times 6, etc. So 4 is in the list, and 9 is in the list. So that means I can just really plug this thing into my calculator. But 2 times radical 4 is 2 times 2, or 4. Notice there's no radical, so I don't have to do anything else with this. Minus 3 radical 9, but radical 9 is 3. So the square root of 9 is 3, and 3 times 3 is 9. So 4 minus 9 is negative 5. Bam, done. Okay. Now these get fun, okay, where we actually have to reduce them. So we have to find the perfect square. So again, this is what we did yesterday. Have your list of perfect squares out. I don't have a list, but I have one in my head. So what we have to do is these are like two separate reducing problems. So I break up the 8 into the perfect squares. Remember, I'm going to do it anyway, aren't I? Okay, look, 8 would go right here. So let's look at this. These are the perfect squares right here. So 8 would be like right here. So the only perfect square that can go into that is 4. So it's 4 times 2. Then either put this in your calculator or know that the square root of 4 is 2. A lot of 2's here. And then what's outside we multiply together. There we go. 18. So 18 would fall right about here. So the perfect square is 9. 16 doesn't divide into 18. 4 doesn't go into 18. So it's 9 times 2. Put this part in your calculator. 3 radical 9. Or know that it's 3 times 3. Or 9 radical 2. Now these are like radicals. They weren't before. There was an 8 and an 18. Now they're like. So I'm going to add the outside numbers together. So I have 4 radical 2's here, 9 radical 2's here, so now I have 13. As long as I added right. Okay, so now this is 3 reducing problems all at once. So I'm going to do this quickly, but you're going to find that you're going to see the same numbers over and over. And 98, the perfect square, is 49. So it's 2 radical 49, put that in your calculator, or it's 2 times 7. So this, it takes time to do each one of these. So reduce each one. Now 32 has a lot of perfect squares that go into it, but the largest one that goes into it is 16. So it's always good to find the largest perfect square. So put this in your calculator, or it's negative 3 times 4. Just remember, bring that radical 2 down, or negative 12, radical 2. And then 18, we just did 18. We know it's 9 and 2. So it's 5 times 3. Remember, put the perfect square and the number in your calculator, or know that it's 5 times 3. And now we just did 14 minus 12. These all have 3's. 14 minus 12 is 2. Plus 15 is 17. I think that looks good. All right, 6. I think this is the last one. Okay, this is an interesting one. All right, so hopefully you realize that 36 is in our list. If you have your list out, it's in the list. So this is just 5 times 6, or 30. Now we do this. We've done 72. This is the third time we've done 72 now. And I wrote the wrong number. Okay, so it's 36 and 2. Remember, you want the biggest one. 9 and 8 work, but that's not the biggest one, and you're not going to have the simplified it completely. So put negative 4 times 36 in the calculator, or it's negative 4 times 6 radical 2. And negative 4 times 6 is negative 24 radical 2. This is a little messy. 27, the perfect square is 9. It's 9 times 3. The square root of 9 is 3. There's nothing to multiply, so we just leave it. So the answer is 30 minus 24 radical 2 plus 3 radical 3. That's it. Nothing is alike. This is just a number. I cannot combine these two because this is 30 and this is 24 radical 2's. So there's nothing we can do there. We simplified. We did our best. Oh well. Okay, let's look over here, make sure. Is this a now you try? Yep. All right, now you give it a shot. Remember to reduce the radical first. Then if you need to, then add or subtract like radicals. Remember, keep the radical underneath the same. That doesn't change. What's outside the radical changes. All right, have a wonderful day.